Hello and welcome. In this video, we'll talk about solving linear and quadratic inequalities, which are basically the first and second degree polynomial inequalities. This lesson's been prepared for students who are taking the Grade 12 Advanced Functions course, MHF4U. We're going to take a look at a couple of examples of linear inequalities, an example of a double linear inequality, and two examples of a quadratic inequality. But before I get started, I would like to take a look or talk to you about some of the language that we use in the process of solving inequalities. So whenever we're solving inequalities, we'll see one of the four signs that I've written down here. The first one means greater than. And then the next one means less than. Next we have greater than or equal to. Or equal to. And last but not least, we have less than or equal to. So, solving inequalities involves a process that is somewhat similar to solving equations. And of course, there are differences, which I will explain as we encounter them. So, to better explain it to you, I chose an example of an equation. Here we go, 2x plus 3 equals 4x minus 1. And based on this equation, I built an inequality, so with the exact same terms, but obviously instead of the equal sign that we have in an equation, I added the greater than or equal to sign. So any of these signs could have been in there, or symbols could have been in there, but that's what I chose. So we're going to solve them simultaneously. So here we go with the first step of the equation. We know that in linear equations, we want to group the variable terms to one side of the equation. So we'll bring the 4x to the left. 2x is already there. And when we take terms from one side of the equation to the other, we switch their signs. So if they're positive, they become negative, and if they're negative, become positive. So in this case, we have 4x to the other side, negative 4x, 3 to the other side, negative 3. So in an inequality, we do the exact same thing as in the equation. So we have 2x and then minus 4x bigger than or equal to negative 1 minus 3. So this step is exact same for both of them. So the next step to solving this equation would be simplify each side. And that's how we do it. 2x minus 4x is negative 2x. Negative 1 minus 3 is negative 4. We do the exact same thing in inequality. So 2x minus 4x, negative 2x, bigger than or equal to negative 4. So far we had to follow the exact same steps for both versions of it, right? For the equation and the inequality. So the next step in the equation will be isolating x from its coefficient, which is negative 2. Which means we are going to divide both sides by negative 2. So we're going to do the same thing to the inequality. And this will be the last step for our equation. So we'll simplify the coefficients. So we have x all by itself. And negative 4 divided by negative 2 is positive 2. And we'll say that we have arrived to the solution. And I always like to box my solutions for some reason. Makes me happy. It's like a small celebration. So we're done with solving the equation. So we're going to continue with our inequalities. Last step. So negative 2 will simplify this negative 2, and the left side will become x. Negative 4 will simplify negative 2, and that will make a 2. So when you are simplifying each side, nothing changes, right? But there is one little thing we need to keep in mind when solving inequalities here. When you divide by a negative number both sides of an inequality, you will have to change the direction of the inequality. So in this case, it's bigger than or equal to, and then you will have to change this to less than or equal to. The reason why we do that, or we do this, because we have divided by a negative number, and this is one of the most important rules that we need to remember that when we solve inequalities. Now, I would say that is a fairly simple rule to memorize. When you divide by a negative both sides of an inequality, you gotta switch the direction. But why? So that's the bigger question. And I want to explain this so that we know why we're doing certain things here. So we know why we are changing the direction from from the division by a negative. Um, so I call this the inequalities big rule. This is not a formal name, by the way, but that's just a sort of dramatic name that I have used to make people memorize it. So this is how it goes. We say that we must change the direction of the inequality symbol whenever we either divide or multiply each side of the inequality by a negative number. And that's what we just did here. We changed the direction of the inequality when we divided by a negative number. But why does this happen? So here's an explanation that I hope you find useful. I've drawn the number line in here, and on the number line I placed the 0 right in the center, and I've actually placed some positive numbers to the right of 0, some negative numbers to the left of 0. So you know that when we place numbers on the number line, they are placed from lowest in the left end to highest. So when we compare numbers, whichever number is in the further right will be bigger than the number that is to its left, okay? And a number that is on the left will be smaller than the number on the right. So negative 3 will be smaller than negative 2, and positive 2 will be smaller than positive 3. On the other hand, 3 will be greater than 2, and negative 2 will be greater than negative 3, okay? Now, this is how we compare numbers, right? So, if we were to compare, for example, the numbers 5 and 4, then you would say that number 5 is greater than 4. Now, suppose that we want to this is actually what we just did in here was practically build an inequality. So if we were to transfer 5 to the other side and 4 to the left side, then our inequality here will change to become negative 4. The other side will have negative 5. And when we compare them, we'd say that negative 4 is right here, right? To the right of negative 5. So negative 4 is still bigger than negative 5. So notice that nothing happens when we transfer the terms from one side to the other. The inequality is maintained here, right? It's kept the same. Now, we are thinking, what if we wanted to compare 4 with 5 in the same positions they are? Is it possible to do that? And we're going to say, well, we learned that as long as we do the same thing to both sides of the inequality, we should be all right. So what I'm going to do is I will divide both sides by negative 1. I could have multiplied by negative 1 as well. Either option works. Then negative 4 divided by negative 1 will be positive 4. And negative 5 divided by negative 1 will be positive 5. Now let's compare the two numbers. Is 4 still bigger than 5. So how would you compare 4 with 5? You would say, so 4 is to the left of 5, so 4 is less than 5. So notice how this time the direction of the inequality changed. And what operation did we perform to the inequality that made the direction change? We divided by a negative. So this is the reason why when we divide or multiply, remember division and multiplication are versions of each other, by a negative, then the direction of the inequality changes. I hope this made sense. And I hope that we're ready now to take a look at our examples. Example 1. We are solving 35 minus 2x bigger than or equal to 20. So we're keeping the variables in one side, so I'm leaving negative 2x on the left side. And we're going to bring all the constants to the other side, which means that negative 35 will join 20 here. I mean, positive 35 will become negative 35 first. So here we go. We'll simplify each side. And now it's time for us to isolate x from negative 2. So we're dividing by a negative 2 both sides. So that will make will give just x in the left side. And the right side will become positive 15 over 2. And now because we divided by a negative number, the direction of the inequality from greater than or equal to will switch or change to become less than or equal to. This will be the solution to our inequality. Now, what does this solution mean, really? So how does it work? Well, first of all, to start with, I really want to make a perfect rectangle here. It's all about perfection sometimes. Okay. All right. So if we were to draw this set of numbers that are less than or equal to 15 over 2 on a number line here. So suppose this is the number line that represents the values of x. And I'm going to say 15 over 2 is somewhere in here. We're going to say that the values of x less than or equal to 15 over 2 will be the solution. So we want to be equal to 15 over 2, so fill dot, and less than 15 over 2, which means to the left of it. So all these are solutions. So in other words, we're going to say that any x value from the interval negative infinity to 15 over 2 with 15 over 2 included in the set, right, or in the interval, will be a solution to this inequality. Well, is there a way to test this or to see how it works? Now, first of all, as you see here, when solving inequalities, we don't have just a single solution or a distinct or numerable number of solutions. We actually get an infinite number of solutions because there is an infinite number of numbers or values of x that are hosted in this interval. Now, how does this work? The way it works is this. Once you know the 0 here, which is 15 over 2, right, or what x equals, then the rest of these numbers must satisfy this inequality. So say, for example, then you choose a number to the left of 15 over 2, which should be in the solution. And I'll pick the easiest number. So I'll call this the testing value. Because we are checking our answers, okay? And as a testing value, I'll take 0. So what this means that if we substitute x by 0 in the original equation, right here, then we'll have 35 minus 2 times 0 bigger than or equal to 20. So 35 minus 0 bigger than or equal to 20. So 35 is bigger than or equal to 20. And as you see, that is true. 35 is bigger than or equal to 20. And we're going to say that works, okay? Now, all the numbers that are in this interval will do the same thing to the inequality. Let's move on to the next example. So the next example, we have 2 times x plus 1 minus 3x minus 1 less than or equal to 2. So first we have to expand. So we have 2x plus 2 minus 3x plus 3 less than or equal to 2. Next thing, group x terms in one side, numbers in the other. So 2x minus 3x, they're already on the left side, so nothing changes to these terms. Less than or equal to, this number 2 is already on the right side, so nothing changes to it. This number 2 will come to the right side, so it will become negative 2. And the 3 will also become negative. Now we simplify each side, so negative x less than or equal to negative 3. One last step we need to follow. X has a coefficient different than positive 1, so we need to get rid of that coefficient. We can either divide or multiply by a negative 1 here. And that will leave us with x on the left, positive 3 on the right. But because we divided by a negative number, the direction of the inequality from less than or equal to will change to become bigger than or equal to 3 in this case. And this will be the solution. And again, I'll box this up. And I'll draw the solution on the number line because that's what it says in here. Here goes the number line. And here goes number 3. And we want the answer or the x values to be 3 or bigger than 3. So 3 or bigger than 3, so to the right of 3. These are all solutions to the inequality. So if we were to write this in interval notation, then we'll say that x must be from the interval 3 with 3 included, which means square brackets, infinity, round brackets. There we go. That's the answer in interval notation. Okay. And you can test your solutions for sure just by picking any number in the interval in here. Now remember though, whenever you test a solution, you must test it on the original equation. Now we're going to move on to a more interesting example. This is an example of a double inequality, and the reason why we call it double inequality is because the inequality symbol will appear twice, so double. In double inequalities, we have 3 parts: the left, the middle, and the right. Okay? There are different ways of solving double inequalities, and I prefer to solve them by using a more synthetic and shorter way I have in mind and that I will share with you. But I will start with a more analytical way, and usually the more analytical ways, which are the ways that explain every single step and break down every single step and explain every concept that has been applied to solving it, usually tend to be a bit longer. But it's better to be introduced to the longer methods first, so that you can understand the insides and the out, the ins and the outs of the process. So let's get started. When we solve double inequalities, we have to keep in mind that a double inequality is nothing but 2 inequalities put together, or 2 conditions put together that must be satisfied simultaneously, so at the same time. In our case, it means that 30 must be less than or equal to 3 times 2x plus 4 minus 2 times x plus 1. And in the meantime, we will want 3 times 2x plus 4 minus 2 times x plus 1 to be less than or equal to 46. Okay, as I said, two conditions must be satisfied simultaneously. So in order to solve them, or the way we see them is as two normal inequalities put together in a system. And when I have to perform such task, what I do is I first simplify the inequality. Now, you have to simplify each part of it, the left, the middle, and the right. In our case, we don't have to do much on the sides, so the left and the right part. We only have to work with the middle. But it can happen that we have to simplify more, right? So in this case, what we're going to do is bring 3 in, 6x plus 12. Bring negative 2 in, negative 2x minus 2, less than or equal to 46. The next thing you want to do is simplify some more because you see you have like terms. Remember, you're not transferring any terms in here, okay? So we are simply simplifying each part in its own space, okay? So we have 6x, we have negative 2x, the like terms, that will make 4x, and negative 12 minus 2 is positive 10. And there is nothing that we can simplify in either part, so we're going to stop here and we're going to build our two mini or regular inequalities. So the left side inequality, which will be 30 less than or equal to 4x plus 10, and the right side inequality, which is 4x, oops, I didn't want to do this, and the other one is 4x plus 10 less than or equal to 46. So I'll put them together in a system and I will start solving, just like I would normally solve any inequality. So I'll bring 4x to the left side and numbers to the other. So I will leave 4x in here to the left side and bring 10 to the other, so 46 minus 10. In the next step, we're simplifying each side, so we have negative 4x less than or equal to negative 20, and 4x less than or equal to 36. Moving on to the last step, we have negative 4x actually we can do this. Okay, I'm going to do it the long way, divided by negative 4, because we are trying to simplify it, and here we are dividing by 4. So we'll say that here we have x dividing by negative 4 will make the direction switch to opposite. So x bigger than or equal to 5. And the next one will be x less than or equal to 9. So once we arrive in here, we are going to find the solution. We're getting very close. And I will draw the number line. Okay, and I will place the numbers 5 and 9 on the number line but we don't have to scale. So 5 and then 9. So just place them in order. So we're going to say that there are two conditions that must be satisfied simultaneously, or x must satisfy simultaneously. It must be bigger than or equal to 5 or less than or equal to 9. So bigger than or equal to 5 and 9 or less. So the two solutions will meet right at -5 and 9, making this the solution to the system, or the solution to the double inequality. So we're going to say that x must belong to the interval between 5 and 9, both sides square brackets, and that is because we want x to equal these numbers as well. Okay, and that would be the solution to the inequality. Now, there is a shorter way of solving this inequality. So if I call this the long way, oops, then the short method will go this way. Now, when we do it the shorter way here, and I'm going to start from here actually, because in the shorter way, you have to go through these steps, just like you did in the longer way. So we'll say that we have arrived to 30 less than or equal to 4x plus 10 less than or equal to 46. So we have simplified each part of the inequality to the best we can. So you can't simplify any more than that. Now remember that the focus to solving the inequality is to isolate x. And whenever we have to do that, we first look at numbers that we need to add or subtract to it. So if we have any constants, it seems that we need to get rid of positive 10 here. And we can simplify or get rid of this positive 10 in here by subtracting it. So if we have 4x plus 10, we're going to say we need to take that away. Now, remember that whenever we solve regular inequalities or regular equations, we said as long as we do the same thing to both parts of the equation, then we're good. But very often we said, oh yeah, just take the term to the other side. But what we technically did was subtracting or performing the same operation on each side. And that's what we're going to have to do here. So 46 on the right side, we got to subtract 10. And 30 on the left side, got to subtract 10. Now, it's a very common mistake people make. They forget to subtract 10 from each part of the inequality because they look at it as transferring 10 to the other side. But when we actually transfer a number to the other side, that's a shorter way of saying we are subtracting a number from each side. And when we have three parts, then people get confused because they think, oh, the term has been transferred already, so I don't have a term for this one here. Please do not forget, same thing must be done to each part of the inequality, each one of three. Okay, so now we have 20, and now we have 4x, and now we have 36. One last step that we need to do in order to solve this, isolate x from 4, or isolate x from 4. So remember, same thing to all three parts, okay? So 20 divided by 4 is 5. In the middle, we'll have x. In the right, we'll have 9. And there we go. We got the same solution as in the previous one. So we're kind of condensing the steps in here. So that's what makes this method shorter. So I'm going to stop in here because I don't want to mix up linear inequalities with quadratic inequalities for now, because quadratic inequalities will require another additional set of skills that are slightly different than linear inequalities. But what I would like to leave you with is an advice. So please practice the homework questions with linear inequalities. You don't have to do 100 of them, just do 1 or 2, just so that you can test how well you can apply what you have learned. Remember that step 1 to learning something is understanding. Just because we understand something doesn't mean that we have made it our own. So understanding is step 1. Step 2 is really learning it. But that can happen when we practice the skill that we have just understood. So I hope that you enjoyed the lesson, and I thank you very much for your attention, because it did become a little bit long. Bye for now, and don't forget to check the next video on quadratic inequality.